Hi, introducing our team member. Our objective is to provide a deeper understanding of the selection and processing of syringe and needle materials in order to minimize waste of COVID-19 vaccine. Using the CES Edu PACS software and materials properties charts and data, the ideas are applied to process and material choices of needle for the syringe.
The main concern in this study is to select the best material by using material selection process. Proper steps are taken to ensure that all materials deeply analyzed. Description for each stage. A. Translate design requirements. Examining the design requirements to identify the constraints that they impose on material choice. B. Screen using constraints. The immensely wide choice is narrowed, first, by screening out the materials that cannot meet the constraints. C. Rank using objective. Further narrowing is achieved by ranking the candidates by their ability to maximize performance. D. Seek documentation. To explore the most promising candidates in depth, examining how they are used at present, case histories of failures, how best to design with them. Material screening. The appropriate selection chart plots yield strength against density. The selection line for the material index has slope of 2. It is positioned so that a small group of materials left is left above it. They are the materials with the largest values of M and represent the best choice, provided they satisfy the other constraint. Ranking process. A method is proposed to deal with multiple alternatives in material selection. It is assumed that all the alternatives in the choice set can be characterized by several aspects and to construct a rating scheme for the various aspect of each alternative. The method basically consists of computing weighted as a comparison through numerical rating. Process selection strategy. Needle syringe. (1) Material. The type of materials you need to use to create product also matters a lot when it comes to deciding suitable manufacturing process. Each material can only be formed by specific processes and using any other process might lead to problem. In this scenario, stainless steel is analyzed to identify specific process to create the needle. The orange-colored table or possible process for the selected material. 2. Shape. Shape is defined as the geometry of the product including details such as texture or finishing. Printing and patterns are also part of the shape of a product. Manufacturing processes cause the shape and different processes are used to make different shapes. With the same materials different manufacturing process can be used, resulting in different shapes. The orange-colored tables are possible process based on the product's shape. 3. Mass. The third attribute will reflect the typical mass range of components that each process can make. In this case the product's mass is 0.0012 is marked below. 4. Section thickness. Process capability and material properties limit the minimum section and slenderness of a product. For the case study, the given section thickness is 0.5 mm is marked below. 5. Surface roughness. For a needle, a smooth and fine surface roughness is important as it going to penetrate with human skin. Low surface roughness will reduce the pain during administration. The required surface roughness is 0.5 micrometers. Therefore, the finished good will through finishing process. 6. Tolerance. No process can shape a part exactly to a specified dimension. A real process usually give tolerances that range from about 10 R to 1000 R. Tolerance and roughness characterize the precision and surface finish of a component, these are its quality aspect. Based on the translation, the tolerance is 0.0127 mm. 7. Economic batch size. The range produced units for a process to be competitive in term of cost. There are about 100 of needles is produced for a batch during manufacturing process. Ranking for process selection. This step is performed to select the best manufacturing process for time reduction. Each process will be receiving 1 mark for every attribute that meet the criteria on translation. Figures show the flow chart of hypodermic needle manufacturing. Description of each workflow of manufacturing process. Milling process. Plain milling cutters are cylindrical in form and only contain teeth on the periphery. These milling cutters are used to create flat, plane, and horizontal surfaces. Rolling machine rolls the flat strip stainless steel into a tube shape. Shaping process. Tube drawing is the technique of decreasing a big diameter tube into a smaller diameter tube by drawing the tube through a die. This method yields high-quality tubing with accurate dimensions, a smooth surface finish, and the extra strength of cold working. As for the hypodermic needle, the tube drawing will produce a mass of 0.0011 kilograms and 0.5 millimeters cross-section. Cold work. Cold drawing is a metal shaping method in which a piece of metal is driven through a single or sequence of dies, lowering the original part's cross-section size. Cold drawing produces a dimensionally uniform end product while increasing yield and tensile strength. As the result, the stiffness of the tubing steel increase. Cutting process. Grinding cutting is the removal of metal by the use of abrasives joined together to create a revolving wheel. When the moving abrasive particles contact the workpiece, they operate as small cutting tools, with each particle removing a tiny chip. This process operates when a tube moves across a grinding wheel to grind and sharpen the tops of the tube into a finer point and shaping it into a rough point. Anodizing process. Anodizing is a process to thicken the natural oxide coating on the surface of metal objects. There are a few types of anodizing process methods, such as by using electrolysis depending on the types of the metal use. As for the stainless steel needle, despite using electrolysis anodizing, the process only requires aluminium oxide solution to be sprayed on the end of the tube. Manufacturing process selection strategy. The manufacturing process selection strategy is defined as the act of selecting the material best suited to meet the requirements of a certain application. A. Translation design requirements for hypodermic needles. Aim. Examining the design requirements to identify the constraints that they impose on material choice. B. Screening. Aim. The immensely wide choice is narrowed, first, by screening out the materials that cannot meet the constraints. C. Ranking. Aim. Further narrowing is achieved by ranking the candidates by their ability to maximize performance. D. Documentation. Due to the requirement needs in hypodermic needles, the selected materials should have the potential to withstand the large amount of stress and maximum load. By this commitment, it is best to say that the stainless steel is the most suitable materials to be used for the hypodermic needle. Effective parameters on the performance of product. Material properties. Fracture toughness. To avoid a broken syringe needle during an injection, a high level of fracture toughness must be maintained. Weight. The syringe needle must be made of a lightweight material in order to be convenient to use when administering the injection. Corrosion resistance. This syringe needle needs to be corrosion resistant. Hardness. The syringe needle must be hard enough to allow it to penetrate the skin and tissue layers during injection, so this material's hardness is essential. Stiffness. The stiffness will return to its original shape when the distortion force is removed after the injection is carried out. Process parameters. Length tolerance. Choosing a shorter needle for a tiny child versus a longer one for an adult will be the ideal option in terms of needle length. Inner and outer diameter. The outside diameter is determined by the gauge, but the inner diameter is not determined by the gauge. Needle configuration. Depending on whether or not it is included with the syringe, the needle may be configured in one of two ways. It may be either detachable or permanently attached. Needle gauge. Needles that are thinner and taller are often less painful to use when obtaining a small amount of medication than a wider and lower needle. Injection method. Both manual and autosampler syringes are used for injections. An injector is a device that delivers a precise dose.